Welcome back to statistics. In this short little video, we want to introduce a new concept and a very important concept. I guess I've said that about all the concepts up to now, but I guess it's true. That's kind of what happens in the first part of a course. The concept we want to talk about today is the concept of a statistical variable. So I want to start out with a couple of slides here, and let's get that up there. So, the concept of a variable in statistics is a little different than the concept of a variable in like an algebra class. It's not something we're going to be solving for or anything like that. A variable is essentially any characteristic that can vary, that can change from individual to individual in a population, is what we call a variable in statistics. For example, if you think about the population of the U.S., if you look at an individual's weight or height or gender or state of residence, and you can probably think of as many as or more as I can here, any characteristic that describes an individual would be a variable. Now, we do distinguish between types of variables. Some variables are numerical in nature, and we call those numerical variables, or sometimes quantitative variables. So, of the ones I've got listed there, weight, height, adjusted gross income, those would be numerical because they measure something. They typically come with units. I mean, it makes sense to think about an average weight or an average height. So those are numerical variables. On the other hand, variables like state of residence, political leaning, zip code, those are called categorical variables because they put individuals into categories. And so for gender, it might be male, female, or maybe non binary, or would rather not answer or whatever. But those are going to be categories. State of residence, that's a categorical variable as well. Each individual has one, and that puts you in a category. Political leaning, however you want to define it, that would be a categorical variable. Zip code would be a categorical variable because even though zip codes are numerical, right, 23941 or whatever, they don't really measure or count anything. They're in essence just sort of codes for categories. Everyone who shares my zip code shares that characteristic with me, but it's not really a numerical quantity I'm talking about here. It has more to do with a post office code for delivering the mail, right? So you got to be a little bit careful in talking about categorical variables. Sometimes variables that may just appear because they look like numbers to be numerical are really just categorical. And another way you see this is like sometimes gender is encoded as numbers. Answer 1 for male, 2 for female, or something like that. But it's still categorical. There's a relationship between this idea of a variable and the idea we've discussed previously of parameters in statistics. Namely, parameters in statistics are really ways of describing variables. A parameter describes the behavior of a variable over an entire population. So, for instance, if our population were USA households, we might be interested in the variable that counts the number of children in each household. And once we focus on that variable, we could then ask, well, what's the average number of children in households across the USA? And that would be a parameter because it describes the whole population. On the other hand, if I ask, well, what's the average number of children in a household that comes from this sample I just took of, say, 100 households? Because I'm talking about a sample, the average of that variable would be a statistic, not a parameter. So these ideas all kind of play together. There are, when we talk about numerical variables, there's some types we want to distinguish. namely discrete variables, which typically are numerical variables whose possible values are just come from a discrete set of points on the number line. A lot of times, discrete variables will be just whole numbers, like the number of children in a household or the number of coins in my pocket. But they don't always have to be whole numbers. For instance, if I talk about the price of a new car I want to buy, that's going to be a discrete variable because ultimately it's going to come down to a certain number of dollars and a certain number of cents. You know, $21,000 and 0 cents. But I don't ever see a price of a car that's $21,000 and 0.00005821 cents. So even something like measuring cash, that's really a discrete variable because it comes in units of cents, and you don't typically measure fractions of a cent. Uh, on the other hand, continuous variables have possible values that come from an entire interval along the number line. So if you think about, for instance, weight, you might usually report your weight as a whole number, like 187 pounds, but really your weight is probably not exactly 107 pounds. So if in the limit of theoretical accuracy, you could get an arbitrary number of decimal points. I weigh 187.283577925 blah, blah, blah pounds. That kind of variable, which could have sort of arbitrary precision, is called a continuous variable. And there's lots of examples of that. A lot of times, discrete variables come from counting, and continuous variables come from measuring, and that's one way to keep those ideas straight. So let's take a look at the ebook and see what it has to say here. These ideas actually are spread through two sections of our ebook. 1.3a talks about the distinction between categorical and numerical data. And let me just take a look at a couple of examples. A lot of times they're obvious, sometimes not quite so obvious. In their first example, they talk about leading causes of death in the USA. And they give the top 10 here, I believe, and this is from CDC. These are the top 10 causes of death. So the variable here would be cause of death. And it would be categorical because each death will be a result of one of these and possibly other causes, but those causes are categorical in nature, not numerical. So cause of death would be the variable, and these categories like heart disease, cancer, chronic lower respiratory disease. Unfortunately, COVID-19 will probably make it into the list this year, but those are called the values of the variable. So heart disease itself is not a variable here. It's a possible value of the variable cause of death. And that's a categorical variable. There was one other I wanted to look at here. Yeah, let's look at beer growlers. A brewery's filling machine is adjusted to fill a growler with 64 fluid ounces of beer. Periodically, growlers are randomly selected and the amount of beer in each bottle is measured. And this is for quality assurance to make sure you're giving folks real close to 64 ounces. So the amount of beer in the bottle is the variable, and this would be a numerical variable, a quantitative variable, and it would also be a continuous variable, right? Not a discrete variable, because even though we want to say 64 ounces, if you actually measured the exact amount of beer in a growler very accurately, it probably wouldn't be exactly 64.000 ounces. You could have anything after that decimal point. So it's a continuous numerical variable. And again, let me just emphasize the glossary of terms that appears at the end of the section. Please read both these sections as a preparation for the homework that's coming up, I believe, in a couple of days. As always, let me know if you have questions. Take care, and I will see you soon.